There is another question we have to ask and answer. We have generally concluded that there is rapid intensification happening, and we kind of get a lot of media attention to this idea that maybe global warming and especially ocean warming is facilitating more rapid intensification events, with multiple rapid intensifications of a particular cyclone during its intensification stage, and so on. And then we concluded that evidence and model process studies suggest that global warming is leading to increase in intensification rates, which means more of the tropical cyclones may be reaching higher categories. So total number of cyclones may not be increasing, but the fraction of the tropical cyclones that are born that are reaching category 3 to 5 is increasing. And Kerry Emanuel himself wrote this short paper, arguing that the evidence exists for hurricanes getting stronger, and he presented it in terms of the potential intensity trend over this period of 1979 to 2018 in meters per second per century. If you remember, potential intensity is where we take the thermodynamic conditions of the ocean and the atmosphere and seek solutions for the maximum sustained intensification, wind speeds, low pressures in the eye, and so on. So that's kind of the upper limit of the intensities. And the other part is to remember that there may be processes that are typically occurring during a rapid intensification of a cyclone. But the question is whether those processes are just random stochastic processes, a confluence of factors that favor rapid intensification, and if so, is global warming somehow making these confluences more common? Is there a favorable confluence of conditions happening more frequently because of global warming, ocean warming especially? Okay, so just to kind of remind ourselves, I have a general article I wrote for the public on rapid intensification, which you can read. But we have these cyclone processes of primary circulation supplying the eye wall, and then we have rain bands with these secondary circulations. And the eye wall, of course, has this tilting structure, the stadium shape we called it, and during rapid intensification you want the convection and the maximum sustained winds to intensify much more rapidly, so 55 kilometers per hour change in a 24-hour period, or a 30-knot change in a 24-hour period. And any such process has to happen in the eye wall, and the other processes can favor such a intensification. And once you have rapid intensification, you will have intensified subsidence and rapid warming of very high rates in the eye wall. And there are also evidences that there is elevated warm core in a rapidly intensifying cyclone, which is typically associated with the process, and so on. So there may be processes that are identifiable among all the rapidly intensified cyclones. That still doesn't mean that they are being they occur more frequently with global warming. That's the key question we are trying to answer here. I don't know what happened there. We had seen this figure before as well when we discussed rapid intensification, just a simple depiction of the processes of early rapid intensification onset member in an ensemble of models which simulated rapid intensification over many instances, and late rapid intensification onset member in the background of this vertical shear. And there is this convergence of the inward cloud bands that are driving deeper convection, more intense. There's processes called convection bursts which happen in the eye wall, which can generate rapid vertical motions, rainfall, winds, pressure gradients, subsidence in the eye wall, and so on and so forth. So compared to this late rapid intensification onset member in an ensemble of model simulations, you can see that these don't have this low level convergence, additional convergence feeding the convection. So the convections are not as intense and are not as tall here, whereas in this early onset they are on both sides here, as shown on the downstream upstream side and the downstream side of the vertical shear. You have these taller penetration of the deep convection into the atmosphere, which indicates more rigorous energetic convection, convective bursts, and so on. Okay, so you have weak downdrafts here and downdrafts with low entropy air, whereas here the downdraft is going to be much higher entropy and create much rapid warming. Jumping straight to this question, are special processes at work in the rapid intensification of tropical cyclones? Again, Kerry Emanuel's group, remembering that he is the world's leading expert on hurricanes and has spent a lifetime on it. The answer is directly probably not. Okay, frequency distributions of intensification and dissipation developed from synthetic open ocean tropical cyclone data show no evidence of significant departures from exponential distributions, though there is some evidence for a fat tail of dissipation rates. This suggests that no special factors govern high intensification rates and that tropical cyclone intensification and dissipation are controlled by statistically random environmental and internal variability. Okay, we will see that we will still need some additional statements on the impact of global warming. So looking at the probability as a log function of intensification and dissipation in as dV/dt in knots per hour, comparison across 5 ocean basins, these are the basins, of the common logarithms of intensity change probability densities derived from open ocean synthetic tropical cyclone intensities of at least hurricane strength using each 2-hour datum. So what they do here is take the best track observations that have been reprocessed and combined where rapid intensification can be diagnosed from observations, and also create thousands, tens of thousands of synthetic profiles where you take thermodynamic states of the ocean and the atmosphere and you keep seeding cyclones into them and see how many grow into major categories, how many rapidly intensify, and so on. And this obviously is a great way to do when you have limited observations, remembering of course that such models, I think it's called the CHIPS model here, it is an intensity prediction system, cyclone high intensity prediction system, or some such model. Sorry, you can look it up. It produces many thousands of profiles which can be diagnosed for intensification rates and dissipation rates, and the differences in basins could well be related to reanalysis product biases and so on. So the tail is somewhat fat in the dissipation case compared to the intensification case, but the rates are basically exponential as seen by this linear line in the probability on a log scale, and that basically tells you that there is nothing special about intensification, rapid intensification processes, that they can happen stochastically by the confluence of favorable factors like warm sea surface temperatures. There are theories proposed for the role of ocean warming on rapid intensification, which is the things like WISHY, the wind-induced surface heat exchange that we talked about, where a warmer ocean can provide more enthalpy for this Carnot cycle idea that we talked about, or generally the moisture convergence into the eye wall supporting convective bursts and processes of rapid intensification. But the question is, do such processes happen on interannual and decadal timescales as well? So here is a paper that looked at rapid intensifications in terms of rapid intensification events, where you take all the rapid intensification intensifications that happened multiple times in a cyclone or single time. So you will get more events than rapidly intensified cyclones, because some cyclones go multiple rapid intensifications during their life cycle, right? So that's what they're showing here as an annual cycle. So for January through December, there is a seasonal cycle. This is for the Northwest Pacific, where more than 30% of the cyclones are born. Very active region, and they only considered this region. And you can see there is a seasonality, even though throughout the year you have cyclones forming throughout the year. Well, at least most of the year you have rapid intensification events and rapidly intensified tropical cyclones. And they also show the ratio of rapidly intensified tropical cyclones versus total tropical cyclones, and rapid intensification events versus total tropical cyclones. And obviously events will be higher than cyclones, because, as we said, each cyclone can undergo multiple events. The main message I want to leave you with is that there is a interannual and interdecadal variability in rapid intensification events and numbers. There's a 5-year running mean here for both the events and the ratio of rapidly intensified tropical cyclones to total cyclones. Does this mean global warming is not having an effect on rapid intensification event numbers? Not necessarily. It just means that there may be a modulation of the internal variability or natural variability of rapid intensification event numbers, and that signal of global warming impact on the rapid intensification event numbers is not yet detectable. This is similar to looking for changes in El Nino behavior itself with global warming, intensity, frequency, patterns, and so on. And right now we don't have a robust conclusion on El Ninos, because models disagree with each other, and the samples we have are not large enough to conclude anything. But same thing could be working for tropical cyclones as well, in terms of rapid intensification, that there may be some impact already. And we said the impact is clear in terms of intensification rates, where the fraction of total cyclones reaching higher categories is increasing, and that is detectable, attributable signal. So we have to wait for rapid intensification, but I wanted to add this podcast at the end to make sure that you remember that this is still a ongoing research and monitoring process, and the challenge of predicting rapid intensification is there, in terms of models not always being able to do it. We said models are ahead of process understanding from observations, but they are capturing many of the tropical cyclone tracks, intensification rates, and so on in most cases. But rapid intensification is not so easily predictable. Maybe process is missing in the model, or lack of process understanding to represent them in the model, and so on. But in the meantime, rapid intensification has to be monitored to see if it is in fact increasing, because that increases the winds rapidly, damages rainfall rates, sea level, inundation, storm surge, etc. So just remember to separate these questions in your mind about global warming and its impact on number of tropical cyclones, intensification rates, and rapid intensification event numbers. Okay.